Hey, it's 6 p.m. On Sunday, March 8th. I can't believe it's March already. Anyway, later on tonight, we'll be joined by Walter Bosley, a man of mystery, who'll be introducing us some new concepts. Uh, so we had to change out like that. And basically, we're finally starting to really shape up in where we're living at right now. I'm in my newest office right now, so it looks really good. And I'm happy to be here. Uh, However, it's been a very sad week, as many of you know. Uh, my friend and partner of many years, Terry Wolf, passed away on Monday. I'm still trying to come to grips with that. Terry's supposed to move here, and he didn't make it. And let's just let that be a lesson there for us all that we don't know what life brings us. We're here one day and we're gone the next. And we enjoy the ride while we got it, and we do the best we can to get as much done as we can. You know, I know Terry really, really wanted to be here. You know, and he put his entire everything behind getting us in this place. It's really a nice place. Um, as you can see, I'm in my new room now, and yeah, the back table was kind of messy. We'll clean that up for next week. You know, but it's starting to look pretty good here. Um, in the meantime, let me remind everybody um, that we have a conference coming up August 12th to 16th. And I'm looking forward to this conference. I'm working on the program right now. Uh, Hopefully, I can get done within the next 2 to 3 weeks, and to the printer. That's my goal. But you know how goals are. Sometimes we meet them and sometimes we can't. Um, I've been been trying to work on it, but this between moving here uh, to this new location and trying to deal with with Terry passing away, it's just really been something else. I mean, Terry didn't know there was anything wrong with them until, just before he went to the clinic and that. And he went he spent almost 3 or 4 weeks, in the clinic, and we thought he was doing good. Thought he beat it, but he moved to Cincinnati, and then he just couldn't couldn't make it. Couldn't make the trip. Uh, that's just so. Uh, anyway, we have a conference coming up, August 12th to 16th. The Right now they anticipate the rooms being starting at 129, and that will include breakfast. This year it's supposed to be improving the breakfast a little bit more, get a little bit more variety there. Uh, I'm I'm amazed at how well we can hold our costs down despite these inflationary times. And so if you can get sign up now. You get a 40% discount. Okay, and in the meantime, this move has cost us a lot, and we really could use some funds here. And so, as a fundraiser, we're going to really push out these magazines. I don't know what's going on here. My computer seems to be acting up now. So Okay, I don't know what's happening with our computer. We kind of just got kicked off for a minute there for some reason. Anyway, right now we're trying to really push our back issues. I have back issues going all the way into the 1990s, with the exotic research report. And we have a lot of information in these magazines and that. The information we have them is every bit as good today as it was back then. And these are people who have written articles in here who are no longer with us. So this is good source material for those who are researching. They're almost like the Reader's Digest, of the technical world, and you get a lot of information in a lot of compressed space here. Uh, one of my pet peeves, is like sometimes you get these papers, by these professors and that, and other people, and they get kind of wordy. And we kind of go through everything, make sure that these people are saying what they mean to say. I take them back, and it really helps them out. So so they're very professional when they come out. And we have different topics, like we have one that's on drones and that. And this is back in 2013, I think. 2013 is our earliest drone picture. No, that might be 2015. But we dealt with drones back then. Now this is before drones were even known. We've had articles on uh, on Tesla coils. We have articles based on anti-gravity. You know, if you go to our website teslatech.info, um, you can look at some of the table of contents that we have posted up there uh, on the main masthead. You know, but those magazines you're looking at $8.95 plus I got shipping and handling. And shipping right these days is it's $10 for one piece through priority mail these days. So so it's better to just get them all. And you have them all there. I mean, it's a stack. I don't know, about a couple inches high. Good. I don't know. Well, if you take about that high, at least uh, a good handful, and it's a pretty good bargain. You know. And like I say, we cover everything. We cover Tesla's technology. We cover how the Hoover Dam was built and everything. And so with that, I'm going to kind of open the floor because it appears our guest hasn't arrived yet. And let's see what else I got for you. Oh yeah, YouTube. I'm having a problem with YouTube. Um, we need to get more people signed up for YouTube. And it's still like our magazine sales, the YouTube, the conference, it keeps us going. Being able to continue bringing new material out all the time, and then some of the materials, that we bring out may seem outlandish at the time, but if you wait, about 10, 20 years, all of a sudden, the stuff that was outlandish and crazy is the hot stuff, that they're working on. The people are just having a hard time catching up with us. Uh, and anyway, our YouTube channel, we hope to increase that. Uh, Tomorrow, I'll be able to start putting more programs up there, or more DVDs up there. It's been a real slog through here. I've been trying to get the computers up and running. We can thank Vernon. He got me a new computer here, and so we can start getting rolling again. By this time next month, I should have the 2024 conference up there, I believe, and then we'll be starting the 2025 in about 4 or 5 more months down the road. It's not going to be immediate. I got to get the conference on free energy coming. I'm trying to get the Tesla Society conference of 1991. I don't have any of those videotapes. If you happen to have the videotapes from 1991 of the International Tesla Society conference in Colorado Springs, please contact me. I have all the other videotapes, I think, you know, and I also have come across uh, a lot of the old programs, which is really cool, you know. This is one of the things that I've been waiting for, is that for the last, I don't know, for the last 10 years, maybe 12 years, I've been separated from my materials because everything's been in storage, you know, and I couldn't get to it, you know. I mean, now we got all this stuff here. It took us uh, three 26-foot U-Haul trucks and their biggest trailer and a lot of car loads to get all the stuff here. But we finally got the stuff here. We're finally going through it. I mean, the stuff I'm finding here is just literally amazing, you know. I'm finding stuff I did 20 years ago, you know, and coming across it brings back the old memories and that, you know. So we'll see how this all works. And we can give kudos to Bernie for helping me get the stuff up. But also, I have my friend here, Rob Milhander, and Rob has helped me also continue to get this place cleaned up and get it organized and everything so we can find stuff, you know. So uh, if anyone knows anything about YouTubes and that, you know, give me a call, you know, 520-252-0374, or write to me at stereoteslatech.info. I could use more information, you know. Um, there's just so much stuff here to learn, and there's so little time to do it. Uh, Terry was really a wake-up call for me. Uh, Terry was like, was 71, now I'm 70, I'll be 71 this year. So yeah, you know, I'm just living on borrowed time, you know. So I'd like to thank you guys for being here. And I don't know if we're going to have our guests. So what I'm going to do here is I'm going to take and open the floor up to anyone who wants to come on and be part of the show. And I'm going to send it out in the comments here. And it's gone. And okay, there's the StreamYard. I sent one out in the comments. And I also sent one here. If anyone wants to share anything tonight, you know, feel free, you know. Tonight's just a really weird day because we all know that the time change occurred at 2 a.m. this morning. And some of us made the adjustment and some of us haven't, you know. And so I like to encourage you all to be part of this. It's looking pretty good. And one of the things I'm really looking at right now is the price of gas. It is unbelievably high these days. And there we go, complete back issue compilation. 3 sets for the price of $200. Like I say, you know, there's stuff in there. I mean, like in our anti-gravity issue in exotic research, we talk about the Hamel device. The Hamel device is the poor man's Searle device. And basically, there's been a book on it called the about the butterfly, you know. Butterfly is something else. But anyway, what it is like it flutters there up and down, you know. He's taking two magnets, like two positive magnets, okay, pushed together, okay. And if it's on a spindle, it will spin, okay. And if you look at the Egyptian drawings, you have like these two people sitting at this pole here, and there's a round thing which is like a rock, and the rock is a mass like granite, and the harder it pushes down, the faster the thing will spin, and that's their form of anti-gravity. Okay, so uh, so that the helmet device, I haven't even heard about that in a long time, but that was very popular. It's a cheap way of doing a solar device because solar requires like road magnets and all this other fancy stuff, but the helmet device didn't require that. And there's a very simple experiment that was in this magazine that describes how you could test this theory out yourself. You know, uh, then we have like the Tesla coils, a magnifying transmitter, and that reminds me, our gentleman here was supposed to have been here tonight and couldn't make it the last second. Parker, he'll be here next week with a thing. Okay, and it looks like our guest is here.
Hey, Steve.
Yeah. Hang on just a second.
No problem.
Yeah. People call me right in the middle of a show. So you want to? Let's.
yeah, yeah. I was supposed to come on there a little while ago and do my presentation with the on the Renegade device, but right at that time, I got an abscessed tooth, and I was in a world of pain. So we never rescheduled for me to come on. Uh, but anyways, I do have some stuff to share. As you know, I've been working on the solid state magnesium power cell technology, which I've successfully done uh, to the point where the magnesium that I use as the sacrificial cathode does not break down anymore. It does not oxidize.
Okay, Mike. Why
Um,
don't you back up a step here and introduce yourself to those who haven't
yeah,
seen you before? And
I'm a YouTuber. I've been on YouTube well over 10 years at Faraday Research, and you can find my YouTube channel there. My archive is of videos is well over 1,000 videos and probably hundreds of thousands of hours of live shows as well. Um, yeah, I started way back, I guess, in 2004. I started working with the Browns gas and the HHO stuff, so that was my first time getting my feet wet in this alternative energy stuff. So it just kind of went from there, little by little, and then I saw, seen John Bedini's work and Peter Linderman and Eric Dollard. I probably watched every single conference that Eric Dollard did, probably about 25 times. So I needed to get up to speed because I never was a graduate in electrical engineering. By trade, I'm a machinist. I'm still a machinist to this day. Um, so I've been in it since, like I said, 2004, and I got, I would say, a fair good grasp on a lot of this technology. And what's really inspired me, I guess, in the last couple of years, other than the Renegade device, that's been an ongoing process, is making basically the holy grail of batteries, and that's solid state. So there's no liquid electrolyte in the cell at all. Um, most companies out there, like CTAL in China, they've pretty much pushed the lithium battery to pretty much as far as it could really go. We need something new other than lithium, and when it comes to energy density, magnesium's actually got a higher energy watt density per square centimeter. So, like magnesium's 3,686 watt hours per square centimeter in volume versus only 2,068 in lithium. So, you got a bigger footprint using magnesium. So the biggest problems with these batteries were the degradation or the breakdown of magnesium, the oxidation problem, creating a proper SEI interface. That's that where the electrolyte meets the sacrificial cathode, whether it's lithium or magnesium, and it creates that passivation layer, is what they call it. And if you get it right, that magnesium or lithium will never degrade. It's like it creates like a barrier, a block, and it's enough to protect the metal, but yet let the ionic flow through that medium. So this has kind of been the big development, I would say, in the last few months, that I've been successfully made a proper SEI interface. So my magnesium doesn't break down. It'll last for years and years. It's also self-regenerating. So if I leave the battery at rest, say like you're charging up a laptop or a cell phone at night, in the morning, your battery's fully charged and the cell that you use to power it will automatically regenerate itself back to its original standing voltage. My new prototype, actually, I just completed tonight, can put out over 30 amps of current. So we're talking some major horsepower in these cells. The other great thing is I'm not seeing the heating up of the plates. It's staying very stable, where lithium has that issue that a lot of people have seen on TV, batteries, going through thermal runaway and exploding. So magnesium has better safety aspects. It takes over 900 degrees before magnesium could actually be triggered. But because it runs on a total different chemistry, you don't get the thermal runaway like a magnesium, like a lithium battery does. So that's kind of where I'm at right now. I can kind of show you what I got here. Let me flip my camera around. So here's the prototype I just built tonight. It's two cells together, and I got them clamped down so it holds everything together. But as you can see, there is no liquid electrolyte in this cell. And right now it's holding a standing voltage of about 5 volts. So each one of those cells is putting out 2.5 volts. So comparing that to see like CTAL in China, their batteries, each cell is holding about 2.5 to 3 volts. Lithium is a little bit higher, but you got your issues. So I'm just kind of testing charging capacitor banks, doing load tests on it with the shunt. And yeah, like I can sustain a 5 amp load on these cells for longer than a minute. And it will sustain a 5 amp load dead, basically a dead short, right? So that's what I've been working on.
So what is this made out of again? This is what,
So
magnesium?
well, the anode is your magnesium. Okay, that's your sacrificial cathode, and the cathode. Sorry, anode is magnesium. Cathode is carbon graphite. And what's in the middle, I can't talk about that. I'm keeping that to myself for a little while. But yeah, I've solved a lot of the hurdles of producing the solid state electrolyte. It's actually almost feels like rubber when it after it sets. One of the big discoveries I made was any aquatis or any liquid in any electrolyte is basically the death sentence for any battery.
So this is
So
a lot lighter too without the liquid.
way lighter. Yeah, and the footprint is a lot smaller now. So now like if you're going to put this stuff, say, in a car or a motorcycle, your footprint for a battery now is like almost half, and the weight has been reduced by, I would say, 70, maybe 80% of the weight. So super light. Like, magnesium by nature is a light alloy, right? So a lot of benefits. Um, I'm seeing good things with this right now.
And how many amps do you get out of this?
It will hold a sustain of 5 amps on a dead short. If I do a very low, say like a 12 ohm resistive load, I'll tap the amp meter and I can hit about 30 amps. So yeah, like spiking, it can produce a lot of current, a lot of current. Um, Internal resistance of a battery is everything. It's everything. So
So
if like,
how many of
sorry,
these have you stacked up?
you can stack as many as you want. Like right now, these are 2 cells that I have right now, and they're putting out over 5 volts at a stable 5 amps. So yeah, I'm right in the ballpark with these multi-billion-dollar corporations that have the lamination machines that cost hundreds of thousands of dollars, and I'm doing this in my house on a shoestring budget. Like,
Yeah.
this is crazy. Like, what I'm doing here on my table in my house is, it almost sounds funny, right? In a way. And I'm getting the same results. I've I've done 2.5 years of extensive research into probably about 50, 60 different, materials that I had to methodically go through one by one and figure out what was the best combination. I knew what the goal was, is to make a solid state electrolyte that has no water in it, and the magnesium would never break down. So now I'll take this cell and I'll put it into a hermetically sealed bag and seal it up. As soon as I do that and lock it, it's done. It could last years. Um, I like some companies out there like Donut. They just recently put a press release out on their new solid state battery. Everybody's saying, "Oh, it's a crock," 400 watt hours, da 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 da. They didn't believe it, and then they just released their very first set of testing of their cell. So it will sustain a 98% of its charge at a temperature of 100 degrees C. Okay, at 100 degrees C, the lithium battery has already exploded at that point. So it is already blown away, basically, no pun intended, the lithium battery when it comes to thermal exposure. Now, the second set of tests they're going to do is probably going to be done about minus 33 degrees Celsius. That'll be the next benchmark. They want to see how hot it can be heated up to and how cold it can be, cooled down to, and sustain what percentage of its output power. And that's really important. That's how they judge the battery, if it's going to actually make it to market someday, right? So, a lot of it, Donut has really actually turned a lot of heads, making this latest press release on their first test results. And it's already beating the lithium battery that's on, widely available right now.
Well, how fast does it
So,
recharge?
my cell will charge within about 10 seconds.
Wow. Almost like
10
fast.
seconds. And it'll run for, I could run a set of lights for probably about 24 hours before it would kind of run itself down. But the second I take the load off, Naturally, this cell is engineered to recharge itself,
Huh.
but I can recharge it. I hit it with a higher voltage, about 36 volts, for about 10 seconds, and boom, it's completely recharged. I have no heating issues, no dendrite formation. Um, I've dissected cells that were running for a couple of months. I would dissect them and inspect the magnesium plate and the breakdown, and I methodically went through this process. So it's a very painstaking process going through all this stuff, but you have to know. You have to know what the limitations are of magnesium, what you can do with it, how far you can push the limits. So the real big one is no water. The second you have water in that system, it's doomsday for the cell. So that's
And
probably one
also,
of the
and also for weight, because like water is 8 pounds per gallon.
right.
And that's why these one of the reasons these batteries weigh so much. You have the weight of the lead, and you have the weight of the water on top of that.
Well, you're probably going to take away about 80% of that weight now using the solid state, because like these cells here are like featherweight. They weigh less than 200 grams. I got a 4x4 inch cell right now, two of them, and they weigh less than 200 grams. So extremely light. So
So
yeah,
these
big plus.
so these would not only be good for the for a car, they'd also be good for like aircraft.
It'd be
You
good
know,
for aircraft because um, the charge time with this is so low. 10 seconds to charge these two cells, that's unheard of. That's totally unheard of. You're back to 100% charge within 10 seconds. Like I could pull the battery down from 5.18 volts down to about 3.20, and I could recharge it back to 5.18 volts with like in 10 seconds, and it holds it. So it's all plus there. It's like, wow, that's incredible. So it's like if you have an electric car and you have all these cells that I've engineered, you can hook it up to the charger, go in and grab your coffee, and come back in 10 minutes, and your car's ready to go, fully charged.
huh. Well,
So
here's a question for you. It's
sure,
like having a supercapacitor. How many cycles do you expect?
in a supercapacitor, almost endless. I've heard of like 3 million cycles for some of the latest supercapacitors.
He's talking about your
So
battery though.
on my battery, I could pretty much put money on, I would say 5 to 10,000 cycles, if not more. I would have to go through some more, obviously, extensive testing on it, but I would say at least 5,000 cycles, no problem.
Okay, and then they want to know. This guy says he's confused because he thought you were looking for material that absorbs water for your cells.
Well, yeah, well, that's kind of a interesting chain of events. The material that I wanted to absorb the water, and then I found a little tidbit online that totally changed my opinion on that. So now I use the materials called sodium polyacrylate. They use it in diapers to absorb water. So when I may engineer my electrolyte, there's going to be water in it when you're making it because it's the only way you can form it. So after you got it in its form, I dump about maybe about 100 grams of sodium polyacrylate on top of it, and as it's curing, the polyacrylate's pulling out all the unwanted water out of the cell, or out of the solid state electrolyte. So when it's done, it literally just peels off. I put it in like petri dishes, like a laboratory petri dish, and it falls right off, no problem. I just take a little knife, go around the edge a little bit, pick it out, and it comes out. It's like rubber. and all the water is completely out of it now because that sodium polyacrylate, it will actually gelify. So it'll actually be like a layer on top of it, and you could actually peel that layer of the sodium polyacrylate off, brush it off, and there you go. Your electrolyte's ready to go. So it's like a preconditioning of the electrolyte.
So do you have an investor yet, or
Sorry?
do you have anyone interested in investing yet, or?
No. That's what I'm looking for. I did have a partner, but right now he's got other things on the go, and his interest has kind of gone in a different direction right now. So I do have like a non-disclosure agreement with him right now, which is going to expire soon. And after that, what I've learned to date now is one thing I didn't tell you the last time. I live very close to George Hathaway. I
Or
am
was he?
literally George Hathaway. He worked with John Hutchison and all those guys back in the 80s.
I know who he is, but where's he living these days? In Ontario,
Oh,
or?
he's still, as far as I know, he lives in Mississauga, Ontario, and his laboratory is there as well. I know where his laboratory is. So I'm like a 30-minute drive away from his laboratory. So he has major funding. He's got DARPA, he's got NASA, he's got Boeing. Um, yeah, he's got quite the facility there. He's working on Casimir cavities, working on anti-gravity, he's working on a whole whack of stuff. So he's very active. He's probably about your age, Steve. And he's still at it. He's a trooper, this guy. He's still right into this stuff.
Well, for those of you who don't know, George Hathaway put together a conference on energy, and I believe it was in the late 70s, early 80s. It
Right.
was prior to the formation of the International Tesla Society in the mid 80s. So, so he's been around, like I say,
Oh yeah. Oh
while.
yeah. When I also know John Hutchison as well. I started talking to him probably about 2006, and when I heard John Hutchison's story, that was the guy who really inspired me in the beginning. He was the guy. So yeah, like, he's so interesting to talk to. Um, Little bit eccentric, but you know that's what makes him so good. You know, and lately I've been, with this battery stuff. I've also been dabbling with some technology. You've heard of a guy named Gabriel Krohn? He's a Hungarian American electrical engineer. He worked for GE back in 1931. That's when he started working there. And he developed, which actually GE actually kiboshed. They didn't want it to come out. He was making a negative resistor
Well, how long have you been doing this?
since about 2004. So I've been around for a little while. Not as long as you guys.
Yeah, 2004. I just coming out of my homeless phase of life.
Yeah.
And
Yeah. So
yeah,
right around that time, I started seeing John Hutchison on TV. Right, he was on the.
I think we might have lost you.
No, I'm still here. Sorry, I'm still here. Can you hear me? Okay.
I can hear you okay. I hear you great. Yeah, I've known John Hutchison for a very long time.
Yeah, he's a good guy. I like to. I talked to him too much the last couple of years. He's had some health issues. So.
Well, Hutchison, I
Sorry.
remember editing an article about paper by Hathaway on Hutchison's work. It's in, I believe it's in our 1986 Tesla proceedings. I don't know if we can do those anymore. That's another thing I have. If anyone knows Gary P, Please let me know if he's still alive because I can't seem to get hold of him.
Yeah, as far as I know, he's still living in Minnesota. He's still with his wife Nancy. So,
You must not be talking
um,
about the same Gary Peterson. I'm talking about the guy who owns the 21st Century Bookstore,
right.
in Breckman, Colorado. You know,
Okay.
and I've been trying to get hold of him for the last year, and I can't seem to get hold of him. And he's
Yeah. Well, Nancy, his wife, she's a bit of a gatekeeper for him,
this
and
guy got
she,
married, so
yeah.
it's not the guy we're talking about.
Oh, sorry, you're talking about the other guy. Sorry.
Yeah, and that's a big problem I'm having. Is a lot of people I know all of a sudden just drop off the grid and you never hear from them again, and you don't know if they're alive or what. And it's a real problem, though. And that's a kind when my partner died, we made sure to get the word out. Uh, we're
Yeah,
gonna do a
definitely.
memorial. We're gonna do
You
a
know,
memorial at the conference. So,
yeah, that's the thing. The older generation, they're starting to disappear, and I think it's good that we're hopefully touching the younger crowd, and keep the tradition of going and and researching this stuff. I've actually stumbled upon a really young, very intuitive, very intelligent young man, and he's been on my show a few times now. Is Elijah Coakley? Actually, I think he would be a very good guest for you on your show. Um, his specialty is like material science and nuclear science. So we had a conversation last night for probably about a good 2 hours, talking about what's going on in my power cell. And I had a couple of anomalies. I had a Geiger counter next to my cell. And when I tapped it, like pushed on it and created like a piezoelectric effect, I created a spike on my Geiger counter. And when I seen that, I go, "Oh God, I gotta talk to Elijah." you know, when you start seeing spikes on your Geiger counter from your power cell technology, it kind of rings a little bit of an alarm.
yeah. So I take it you're outside, right?
Yeah, I'm just outside right now.
Yeah, 'cause that's a lot of the wind noise.
Yeah, I apologize. Here, I'll try to block it.
So it must be cold out there.
It's warmed up quite a bit now. We're above zero, thank God. It's supposed to be 17 degrees Celsius. So it's supposed to be about maybe around 50 Fahrenheit, I think. So it's starting to warm up. We had a really harsh winter here in Toronto this year. It was like minus 30 some nights Celsius, which is like, I don't know what that is in Fahrenheit. Sorry.
Well, there's something a lot of people may not be aware of. Like every time that the stratosphere is warming up, and it's been doing that a lot, you get these polar vortexes coming out of the polar regions, and that's how come it's been so cold lately. I think we're supposed to get one more, you know, and it's just a product of global warming. I know I'm going to catch hell for people, don't like hearing about global warming, but it's a real thing, and it affects the weather in strange ways. You just gotta, study the effects on it, and so,
Yeah, I don't really, I don't personally really buy into the global warming thing because, like, when you think about it, we've only been really scientifically tracking weather for what 120 years. So they're trying to predict something that they've never actually proven in data. So,
well,
say you were able to track winter trends for, say, a period of 2 to 300 years. Okay, then you can make a little bit more of an accurate assessment if the planet is warming up or not.
Mike,
So,
they have a record of it. It's in the that's the kind they send these poor guys out and they drill these ice things because they could tell, and they measure everything, the atmosphere. They can tell you so much. It's just incredible, you know. And And one of the big things we have to be on the lookout for, like in the Arctic, for instance, like in the Siberia, they have these huge round craters now, and that's basically the methane melting, okay, or the ice melting and releasing these pockets of methane out, and they, you know, and stuff like that. And the big danger here is you have germs and viruses that have been frozen for all these hundreds of years that we haven't been exposed to, and now they're going to
Right.
be coming out, you know, and
Yeah. Yeah. That's true.
you know, so
So, but you know what? The way I look at it, I don't think it's going to happen in my lifetime. Maybe in my daughter's lifetime. I don't know, but
well, I tend to look at it this way. Mother Nature, she acts slowly, then all of a sudden you get that abrupt transition. That's what makes an earthquake so devastating, is because it's like slowly along, then all of a sudden, boom, it makes a big jump, and that's where all the damage comes from.
right.
So, but yeah, the Earth is constantly changing.
Yeah, it's normal. Earth changes. There's going to be fluctuations in the atmosphere. Um,
Yeah, but we have to be prepared for it. You might not be able to
true.
stop the change, but you can prepare. You can build buildings so that they can withstand things. And not build in
Yeah.
a flood zone. It's just a
Yeah.
lot of little things you can do. And look at
Yeah.
technology like your battery, for instance. And
Yeah. Exactly. So, like, I'm a real big supporter of a decentralized power system. I think
me
we're in a
too.
day and age. I think we're in a day and age right now where, the system that too volatile and unstable.
Well, I'm looking at if we were. I'm not a fan of one size fits all on anything. But I believe in hybrids. Like maybe you have a lot of decentralization, and like I drive to Henderson. It's about 40 miles away now, and I drive through this valley, and they're just throwing up all these solar cells, up this valley, and it breaks my heart because solar's great, I think, to some degree, but they're destroying the desert doing it. And the better solution would do what the VA does. They took their entire parking lot and covered it with solar cells, so that everybody has a covered parking spot, and they uh, they use a lot of that power in the hospital. You know, so we just got to be smarter, and unfortunately, I don't see that happening.
Yeah,
You know,
it's going to take like a scary event. I think. Remember back in I believe it was 2003 when the whole eastern seaboard went into the dark, including all the way
oh yeah,
from Quebec and Ontario and all the way down to I believe Georgia and some parts of Florida went in the dark as well. A lot of people forget that event. I remember that event very, very well. And like you can imagine, like just like your local supermarket, how many thousands of dollars in food that spoiled within that time frame, which would cause a huge problem for the food chain to sustain society, right? We're very fragile that way. If our power goes down, we got problems, big problems.
but
And
there they tried to some branch falling on a power line, and that's because the utilities would rather spend money on lobbyists and bribes the politicians rather than do what they should do and do their maintenance. And
yeah,
they
no,
pay the maintenance tax and would have saved a lot of
yeah,
money.
yeah, it's the bureaucracy that goes on, all the politics that takes forever. And, they're spinning their wheels 90% of the time, not actually trying to come up with solutions that, possibly could happen. Say we get a solar burst from the sun, like they did back in, what was it, 1858? We had that huge solar burst that basically took out all the telegraph in on the East Coast, basically wiped out everything in New York City. All power lines blew up for the telegraph system, so that could very well happen again.
Yeah,
You know,
good.
we're you know
And then look what we're doing. We're putting our internet up on SpaceX there, you know? I mean, uh,
Probably the word in like functionality wise, it's practical, but being exposed to cosmic radiation, you're a sitting duck, right?
well, it's also polluting the upper atmosphere because those satellites are going through the upper atmosphere, and each time it passes, it's a little bit gets knocked off in there, and next thing you know, a little bit adds up to a lot. You know.
Yeah, you got a lot of space junk up there. So if you're trying to send up spacecraft with humans on board, you got to worry about all these particulate that are in the upper stratosphere, orbiting the planet. One little tiny piece of fragment, the size of a dime, could be catastrophic for a spaceship,
Yeah.
right?
Well, what I like
Or
what I like about your batteries, though, you can use those in conjunction with these solar cells and that, and wind.
yeah,
In one of our back issues, I think it's probably about volume one, issue 2 or 3. We talked about this little windmill where she took a half twist to like a Mobius strip and used
right,
that for a windmill, and you could get power out of that as low as uh, 3 miles per hour. You know,
yeah,
but you
yeah,
figure you put those along the ridge of roof, you wouldn't even know it's there. It doesn't kill birds, and it's producing power all the time and can help the solar cell technology. I mean, there's so many things we could do, and then you have a
yeah.
battery collecting that energy and storing it, for release.
Yeah, exactly. And I think the next step for battery technology is not only that you want a high energy density and amount, high, kilowatt hours on batteries. It's the charge time. You get the charge time down to under, say, 15 minutes. You got something special because now it's like you go into a gas station and filling up your tank of gas and go grab a coffee or some food and come back, and then your car is fully charged and you're on your way again. And also we're able to go further and further with these batteries now, which is comparable, in comparison to a gas car. So now, the internal combustion engine, theoretically has been obsolete for, longer than I've been alive, in my opinion. They just never bring it out because it's all the bureaucracy and the control of the oil companies and the energy corporations. You know, we have to do a complete strip down and reorganization of the power distribution system, and the methods on which we use to run our society. It's over 120 years old, and we're still using the same methods. This has got to change. This cannot be sustained.
So, how flammable are your cells?
Sorry.
How flammable are your cells?
They will run away. Well, magnesium will run away at about 900 degrees. So they have to get up to a pretty high temperature in order to actually explode. Where lithium, it hits over 100 degrees Celsius, you got problems, big problems.
Yeah, because
So,
that's the concern with like the Tesla wall. It's supposed to be lithium batteries and that. No, it's like kind of
yeah, you get that into the Mojave Desert, or any desert in the U.S. It's going to go over 100 degrees. I'm sorry, and those batteries they're gonna fail.
I live in the middle of the Mojave.
Yeah.
I
So
mean, I'm south of straight south of Nevada. And you can see Joshua trees all the way from here uh, up to Las Vegas. I used to live in Arizona. That's the Sonoran Desert. And there they have a different type of saguaro cactus. It's the signature cactus there. You know,
yeah,
but yeah, either place you look at hundreds and hundreds of degrees. And I lived in a trailer, and it got so hot in the trailer, I literally pass off out at my computer and
yeah.
get revived as soon as the sun set. I revive and get back to work. I mean, uh, So yeah, it's hot,
Yeah, it's hot. Yeah,
very hot.
and yeah, the lithium just won't cut it. You're gonna have too many thermal runaway issues. Magnesium needs 900 degrees to catch on fire.
Yeah,
So
yeah, it gets so
yeah,
hot. We used to have these Fresnel lenses, you know, and that you can concentrate like the sun, and
right.
we'd take them out in the parking lot and pop the concrete with the heat.
Yeah,
It gets hot, you know.
yeah. And the other thing too is like there's two other technologies that I think have real good potential in the next little while. Actually, France and I think Belgium are working on flywheel storage, energy storage, making these giant flywheels, running them in a very controlled environment, and they can store a lot of energy for a lot of time, and takes very little amount of energy to sustain the spin. NASA's also worked on it extensively for the space station. They have one up there now. They had one running consistently for 3.5 years nonstop.
Well,
So,
I worked for Unisys, formerly Sperry, and for our test equipment floor, we had like a motor generator, and it had a huge flywheel on it. And what would happen is, first of all, you clean out the power. You know, you have the dirty power go in, the power of the motor, and you have clean power coming out the generator. But the big advantage is like when the power gets cut off, like it did one year because they had a blizzard and you know
right.
knocked out the electricity.
Yep.
Uh, it gives us like 20 minutes to shut all the equipment down.
Yeah. Yeah. Which is
So
really helpful. But,
yeah,
these generators that they've been building out in France, uh, they're huge. Like they're like look like silos. They're massive. Hundreds of tons, and huge amount of current storage, and which is actually they've actually put it into the power grid system. It's actually running part of their power grid. So
yeah.
the other one is Stirling engines. I've
Well,
seen a few people working on some really interesting Stirling engines that are very efficient.
I'm hoping to get my videotapes from the Tesla Society converted to DVDs because
Mhm.
we have a gentleman who came in there and he had a whole trailer full of different types of Stirling engines, you know, and he was
Yeah,
demonstrating at our conference. Yeah,
yeah, yeah. There's a few companies out there that are seriously looking into bringing back the Stirling engine.
yeah, because you can operate off of either heat or cold, you know.
Yeah,
Um,
heat or cold, you geothermal energy, solar energy, you name it. As long as you got that temperature differential.
yeah, that's all it takes. And then if you're like in spacecraft, you know, I'm
Hmm.
surprised they don't use them more because on one side you have hot and the other side you have extreme cold. You know, perfect. You
Yep,
know,
that's perfect. They'll run a Stirling engine. Yep.
yeah. So yeah. So anyway, I'm gonna guess we're approaching an hour, and I thank you for being on here. Is there anything else you want to
Yeah.
say, or
Yeah, that's
I,
pretty much it. I gotta head to bed soon too. I gotta be up at 4 a.m.
yeah,
Wife's getting some surgery done tomorrow, so um, I gotta get up early and get her to the hospital. And
very important. I have the same issues too. So
yeah,
yeah. So except
thank yeah,
I live
thanks
so
for having
far.
me on.
I live like 45 minutes from anywhere. You know. So when I go
Yeah,
to a doctor or take her to the doctor, you know, it's at least a 45-minute drive one way. You
yeah.
know. And now we're looking at this
Um.
gas prices going through the roof.
Oh yeah, it's right now it's about $1.52 a liter here in Canada, so it's like 4.50 a gallon, something like that in the U.S. now. Correct me
That's
if I'm
pushing
wrong.
up there. We're pushing. We're starting to get pretty close to four right now down here.
Yeah, yeah.
Yeah, I know in California they're way past that. Now they flew past that a long time ago.
Yeah.
So But yeah,
Anyways, thanks a lot, Steve, for having me on. I was happy
thank,
to jump in there.
thank you for coming on, and we'll have to do this again sometime. You know,
Yep, sounds great. Yeah, we'll hook up with Bernie again, and we'll do another show together.
and well, Bernie will be back, or he's gone this week, and at least maybe for
Yeah,
a week or two. But then he'll be back here.
right.
Before he heads up to Canada.
Yeah.
And back to the code. I can't handle it.
Yeah,
So
it's
okay,
early spring here.
okay. Well, thank you, and thanks for being
Okay.
on.
Yeah,
And I
thanks
like.
a lot. Take care.
Okay, you too.
Take care. Bye.
And what I want to remind everyone is don't forget. We're having our complete back issue compilation sale. It's our form of a fundraiser, and I hope you guys will get these magazines. The great things about these magazines is you don't have to worry about the power going down. You can read them by candlelight if you have to. And so there's a lot of material there, a lot. You're looking at 40 years worth of material there. And you're not going to find this anywhere else. And a lot of people wrote this stuff. Unfortunately, they're no longer with us. And so anyway, I'll be seeing y'all next week then, and you have a good weekend. We'll get together next Friday. Thank you so much. And maybe we'll be able to get with Parker, and he's going to tell us all about his Tesla magnifying transmitter. Thank you so much.